Okay, here we go. What is the length of line segment QR? Reminder, this is a perpendicular, there's why it's perpendicular, it's got the box there, bisector. It cuts it in half. Line SR is a perpendicular bisector of QT. Any point on that perpendicular bisector will be the same distance from the endpoints. So here the equation we're going to set up, 2x plus 3 would have to equal 4x minus 7. Let's solve it in our head. Dylan Davis, move the 2 x's to the right side. How many x's do I now have? Good. Move the minus 7 you now have. So x must be good. Which is an answer choice, notice. 5, that's wrong. Make sure you plug it in because it's not asking for x. It says what is the length of segment QR. QR is 2 times 5 plus 3, which is 13. Go ahead and plug it in here to check it. 20 minus 7, also 13. So length of QR would be 13 units. I will explain 29. We're not doing yet. If we have time at the end, I'm going to go back and do what's called constructions. You can actually, with a compass, you can find a perpendicular bisector really easy. See if you can follow this. If you have a line segment, you could take your compass and open it to any, and a compass, one of those things that draw circles, okay? Take your compass and just open it to anything wider than halfway and keep it set there. Keep it to that distance and measure or draw an arc. Okay, you don't have to draw the whole circle, but just draw an arc right here. With the same opening, come over to this other side and draw the exact same arc. Connect the dots. Look what you've got. Perpendicular bisectors. Here's why. We just learned that any point on the perpendicular bisector is the same distance from A as it is from B. Do you see how that fits? When you open, let's say that you open your compass to 6 inches, and you strike this 6-inch arc, this 6-inch half circle, and this would also be a 6-inch half circle. Well, if it's 6 inches from here, and it's also 6 inches from here, if a point is the same distance from here as it is to here, it has to be on the perpendicular bisector. Same point down here. This is 6 inches away, and this is also 6 inches away, so it must be. Those 2 points have to be on the perpendicular bisector. The answer there would be C, but that one won't be on your test. Number 30, also not on your test. It's also another construction. It's about constructing a line parallel to a given line, so we can skip number 30. On to 31. If 2 angles form a linear pair, hey, this is review. If 2 angles form a linear pair, Thaxton, then they must be supplementary, B. They're not congruent, they're not vertical, they're not complementary. Vertical angles are actually congruent, so that's they're supplementary. Number 32, line M is parallel to line N. Therefore, Kobe, the 2 angles that are given, which are what type of angles? They are both right angles, and the relationship between the two are corresponding. These 2 corresponding angles have to be congruent. So like he said, they're both right angles. So your equation there, 5x minus 20 would have to equal 90. And if you set that up and solve it, 5x minus 20 would have to equal 90 in order for that to be true. Move the 20 over. 5x would have to be 110. Divide by 5, you get x is 22. But always make sure what I'm asking you. Find the value of x. Okay, we're safe. C, 22. And number 33, which I believe is the last problem, sure enough. Number 33 says the 2 lines in the figure below are parallel. What is not true? That's actually the exact same shape. Remember that proof we did the other day that I had a little trouble with? It's the same one. Now I'm giving you, we're working a little bit different now. It says they are parallel. Let's assume that we have parallel lines.